Hello and welcome to Math with Mrs. Becker. Today in Calculus we are going to look at section 4.4, which talks about the natural logarithm function. So remember, when you have a log, they always have a base. What a natural log means is that you have a log with a base of e. So rather than writing it as log with a base of e, they write it as ln. So it is your natural log. Because we're working with logarithms and also bases, okay, so that exponential idea, we do have some properties that we can look at before we move into the problems. If I have y equals the natural log of x, that is the exact same thing as x equals e to the power of y. And this is how I know that. Remember, in order to cancel a natural log or an e, as soon as you have an e next to a natural log, they would cancel. So if I wanted to solve for x in this case, I would need to give both sides a base of e, because e to the natural log would cancel, leaving me e to the power of y equals x. And that's what it's saying right here. Here's another property. The natural log of 1 is always 0. And that's something that we can always go ahead and check on the calculator. There is a natural log button. If I go the natural log of 1, we can verify that yes, that is a 0. If I have e to the natural log of x, it's going to equal x. That's because, again, e to the natural log will cancel, so all you have left is x. They're telling me for any values that x is greater than 0. So with this domain, what that tells me is that the natural log is really only defined for positives. So let's check that out. What if I have the natural log of a -1? Oh, that doesn't work. What if I have the natural log of -100? Oh, okay. So what this is telling me is this property works, but x has to be greater than 0 because I have a natural log of x. And you can only have a natural log of positive numbers. They have to be greater than 0. Okay, and so right there, it's like, oh, greater than 0. Well, what happens if it's equal to 0? Natural log of 0 is also a domain error. Okay, for every positive number x, the natural log of x is the exponent that you would have to put on e as a base in order to get x. Okay, you can do the same thing here. If the natural log is in front of e, if they're connected, bam, you just cross them off, so it's going to be x. That's what you'd have left. So we're going to go ahead and use these properties and just simplify. So number 1, do not think too hard about this. I have e to the natural log. This cancels this. Your answer is 4.1. That's all you have left. What you need to realize here, this is a logarithm. Remember when you write out logs, you would put the exponent in front? Well, right now I cannot cancel e in a natural log because there's a 4 in the front. What that 4 really is, it's an exponent on 1. So this is really e to the natural log of 1 to the power of 4. Now that I sent that exponent back, e and the natural log are touching, so they cancel. 1 to the power of 4 is just 1. Same thing here. This too, if you have a number in front of a natural log, it is an exponent. So this is equivalent to e to the natural log of 4 plus the natural log of 3 squared. Before I cancel this out, like I can go ahead and cancel this, but that would be kind of pointless because we'd still have a natural log. I can condense these. Remember, adding goes with multiplying. So I would have e, because this is a natural log and this is a natural log, I can write it as 1. Adding goes with multiplying, so I would take 4 times 3 squared, which is 9. So that gets me to e to the natural log. 4 times 9 is 36. E to the natural log cancels because they're next to each other. Your answer here is just 36. So it's being able to use all of those exponent properties that we've been looking at so far in this chapter. Let's look at another one. Again, if I have a number out front of a logarithm, whether it's a normal log or a natural log, that number is actually an exponent. So this is the same as e to the natural log of 3 minus the natural log of x squared. I can condense these because they're both a natural log. Minus goes with division. So it would look like this. E to the natural log 3 divided by x squared. E cancels a natural log. I can't simplify anymore. So number 4 simplified is 3 divided by x squared. That's it. Okay, here, e is a base and e is a base. You cannot have e as a base 2 times. So what I have to do is condense it. So I'd have 1e, because you're multiplying, remember you add the exponents. So this is really the natural log of e to the power of 2. Natural log and e, as soon as they're next to one another, they cancel. Your final answer would be a 2. So this is what 4.4 is looking like, you guys. Just being able to work comfortably with natural logs and e's and kind of knowing when you can cross things off, how do you condense them, where does that number go in the front, remembering that it's really an exponent. Last part of 4.4, and you guys, this isn't like a part 1, part 2. This is the entire section. If you want to solve for x, what you need to realize is that if you have natural logs, in order to cancel a natural log, you need to bring in a base of e. If you have an e, in order to cancel it, you need to bring in a natural log. So let's go ahead and solve some equations. Right now, I could not take the natural log of both sides and cancel an e because that 5 is in the way. So step 1, you would want to get rid of that 5 by taking 4 divided by 5. So I'd have e to the power of x minus 3. 4 divided by 5, you could leave it as a fraction, or you could put the decimal representation 0.8. Now, to cancel an e, you take the natural log. Natural log cancels an e, so I have x minus 3. Natural log is on the calculator, so I have to take the natural log of both sides. So when I hit pi, the natural log of 0.8, it's going to be an approximate answer. So I have to switch from equals to approximately, and if I look at this, it's negative 0.223. Last step, if I want x all by itself, I need to add the 3. So x is approximately, if I take negative 0.223 plus 3, I get 2.777. Again, I switched that sign to approximate, showing that I did round. Here's the next one. I notice that I have e as a base 2 times, so I will need to condense them. But first, let's cancel these parentheses. Properties of exponents. If you have an exponent inside and outside of the parentheses, you have to multiply them. So this is e to the 2x times e to the 2 minus 3x equals 4. Now I condense these because they both have a base of e. I get to write the base of e 1 time. Multiplying goes with adding, so I am adding these 2 exponents. What you do when you're adding, because notice I have variables and some constants, you're combining like terms. So 2x plus a negative 3x is just negative 1x plus 2. Now that I got rid of the parentheses, I condensed my bases down to 1. To cancel an e, you have to take the natural log. What you do to one side, you have to do to the other. Natural log cancels e, leaving me negative x plus 2. This is going to be an approximate answer. I need to take the natural log of 4. I would have approximately 1.386. Now I go ahead and I solve. So if I have 1.386, the first thing I'd want to do if I'm trying to solve for x is I'd go ahead and minus 2. 1.386 minus 2 is a negative 0.614. Divide both sides by a negative 1, and x is approximately a positive 0.614. Oh, sorry about that. Okay, here we go. I'll slide up a little bit. So we are simply just solving equations. Next one, and this is our last question, and then you can jump right into the practice questions in the textbook. If I want to solve for x, I know I have to cancel a natural log. Well, to cancel a natural log, you have to have a base of e. But first, I'm going to go ahead and isolate this so I can minus that 7. So 2 times the natural log of x would equal a negative 7. If I take a base of e right now, it's not going to work because of that 2. So I can go ahead and move that 2 over. So I'd have the natural log of x equals negative 7 over 2. You could leave it as a fraction or go ahead and do the decimal representation, which is negative 3.5. To cancel a natural log, you take both sides to a base of e e to the natural log cancels, so x equals, e is right here. It's above the natural log because they kind of go together, so they're on the same button on the calculator. I have to hit the second ln button. It's e to the negative 3.5. So again, I will have to approximate this answer. So x is approximately 0.03. And you guys, that is it for section 4.4. There are 21 questions in the textbook that I feel are really good practice going over these skills. Let me know if you have any questions. I hope you had a great time today, and I'll talk to you soon.